squares long it is, you know. Yeah. Then on the bottom, but in a rectangle, you normally do it right underneath, wouldn't you?
Yeah.
So move it to the side.
I don't really understand.
Yeah, try again. You can't do it. It's fine. Yeah?
I think I get it now.
Just try it. It's about the problem solver. Okay, just another minute on this. Should be quite fast. This kind of thing. It's basic algebra, but algebra can be quite tough in its own right. Please check question 7. Think about, have you definitely got question 7 correct? Have you definitely done it correctly? Think about bid maths. Should have been taught bid maths before, most of you. If not, lesson tomorrow is all about bid maths and problems like that. Okay, right, we'll go through these so we get to the hardest stuff. So the first one, n equals 4. So we're doing n plus 6. So question 1 is 4 plus 6, which equals 10. So you should have 10 written down. You don't need to do any working out for these. Some of them I would recommend doing some working out. I'd recommend writing down what I'm writing on the board. It just helps you check your answers as well. So question 2. So for question 2, you're doing 4n, 4 times 3 is 12, plus 2 equals 14. So that's a working out I like to write down. If you want to write down more than that, absolutely fine. But I think that's a good amount to do. Question 3, n is 7. So we've got 3 times 7 is 21, take away 25. If you try and do that in your head, you might get an answer of 4. But it's not going to be 4 because 21 take away 25 has got to be negative because you've not got enough that you're taking away from. So 21 minus 25 is negative 4. So that's another reason why it's good to write these down first. N is 4. 10 take away 4. This is another one where people get the negatives mixed up. This is saying 10 minus 4. So question 4, 10 minus 4, then stop and look at what you've got written down. 10 minus 4 is 6. Not negative 6, just 6. Question 5, similar question. These ones are very commonly messed up. So we've got 5 take away 2n. Now 2 times 3 is 6. But if you get 6 and 5 in your head, your brain's going to come up with 1. But if you write it down, 5 minus 6, the answer is negative 1. Write some stuff down. Don't do everything in your head. Right? Question 6, squared means multiplied by itself. So for question 6, n squared is 3 squared, which is 9. 3 times 3, and then 9 plus 10 gives you 19. And question 7, potentially the hardest question on there, 3n squared. We square before we times. It is just the n being squared. So we are doing 5 squared and then timesing it by 3. So it's 3 times 5 squared. 5 squared is 25. So it's 3 times 25, which equals 75. If you've got 15 squared down there and try to square those together, you've made a mistake. So if you've got 225, you've done 3 times 5 and then squared it. You've done something different. So think carefully about when you are squaring values. You are only squaring the letter that it's next to. Or you're using bid maths because the I in bid maths stands for indices, which always comes before divide and multiply. Okay, so a bit of a warm-up there. That's what algebraic sequences are all about, being able to do that. If you can do that, you can do this tough topic of sequences. Okay, so a bit of another kind of easy warm-up for you. Quite simply, all I want you to do is a sequence follows a set rule that applies to every term. So the rule is the same throughout that sequence. You can't change it as you go. Most of the rules are to do with adding and taking away. Some of them you might be multiplying or doing something a little more sneaky. So all I want you to do is quite simply look at those sequences and write down the next 2 terms in each of the sequences below. The next 2 terms is all you need. Okay? In fact, we'll go 3 terms because I'm sure I've got 3 in the next one. So we'll go the next 3 terms you can do. So the next 3 terms of each sequence is, because I think I put 3 in the answers. So just write down the next 3. So it goes 7, 10, 13, 16, and then you're doing the next term, and the next term. Okay, so that's all you're writing down for that one there. Alright, so a few minutes on that. They get a little bit tricky towards the end. Some different sequences that you see in GCSE. Draw a parallelogram, let me show you what you do. You do one side here, so I make that 5 squares long, yeah? 1, 2, 3, 4, 5. Now for a rectangle you do that. Now I'm going to move it across and do my 5 squares here. 1, 2, 3, 4, 5, and then what can you do? Okay, so can we do these with rulers here? I think using rulers is really important skill. Okay, good, you've got the right idea though, which is really good. Okay, so we're just finishing the sequences off. You've got 4 numbers out. I want the next 3 in each one, the next 3 numbers in each of those sequences. Please let me know if you need any help. Okay, if anyone's just turned up, we are just looking at those sequences, just a couple more minutes. We're just trying to fill in the next 3 terms in each one. So these are the easiest questions you will get in your GCSE. They give you a sequence and they say, just write down the next ones. Okay, you don't even need to explain the rule, but if you don't work out the rule, you're not going to be able to work them out unless you are completely guessing. So these are the easy questions that you need to make sure you don't make any silly mistakes with, and then it gets a lot more difficult after that. The last one is tough, but it came up actually last year, or maybe it might have been in the November exam. The last one is a tough sequence. It's a very famous sequence called the Fibonacci Sequence. And you are actually in the new GCSE expected to know what the Fibonacci Sequence is, which is why I put it on. Very different to the other sequences you do, but it's called the Fibonacci Sequence. I'll give you a clue. Look at the previous numbers in the sequence to work out the next number. So the next number is worked out by looking at the previous numbers. Not all of them, but some of them. For the last one. See if you can work it out now. It is a tough sequence. Unless you know how to do it, then it's actually quite an easy one. What's wrong here? Okay, let's have a look at these. So, first one, in fact I've got the answers here. I'll go through the Fibonacci sequence in a bit as well. So we had 19, 22, 25, 1, -3, -7, -1, 1 and 3, 5, 5.56. You can use 5.5 if you want instead. This one here is each time it is doubling. So you're doubling it, doubling it, doubling it. So it's 48, 96, 192. And this one here, they are your square numbers. Or the gap goes 3, then you add 5, then you add 7, then you add 9. But you should spot these as your square numbers. 1 squared is 1, 2 squared is 2, 3 squared is 9, 4 squared is 16, and so on. If you look at the gap, and it goes in this gap of going up in 3, then 5, then 7, then 9, then 11, you know it's to do with square numbers. So that's a good thing to look for, and always check more than one gap. So don't look at the first one, it goes up in 3s, and just add 3 on. You're going to check more than one gap. And the last one is a Fibonacci sequence. Okay, to get the Fibonacci sequence, you add together the first two numbers to get the next number. So 1 and 1 is 2. 1 add 2 is 3. 2 add 3 is 5. 3 add 5 is 8. 5 add 8 is 13. 13 add 8 is 21. 13 add 21 is 34. It doesn't need to start from 1 and 1. If it doesn't start from 1 and 1, it will say in an exam, it will say this is a Fibonacci sequence, which is a famous mathematician who came up with this. It's a very interesting sequence. It's used a lot in natural life. But there's loads to do with that. But all you need to know is you add together the two previous numbers to get the next number. Okay, so that's your basic sequence that I'm sure you all know already. Going to move on to the algebra side of it. Okay, so harder sequence involve using algebra. Okay, harder sequences involve algebra. The nth term is what it's all about. The nth term is a formula that tells you what the sequence is going to be. So if we had a sequence of 3n plus 1, this is going back to the first thing we did. And what you need to do is you need to choose your n numbers and work out the answer. So if we've got 3n minus 1 here, okay, the first thing I'm going to do is I'm going to say, first of all, n equals 1, because that is my first term. This means the position in that sequence is number 1, the first one. So if n equals 1, okay, so if n equals 1, I'm going to get an answer of 3 times 1, which is 3, minus 1, which gives me 2. That's my first number. For my second number, I'm going to say that n equals 2, 2 for second. So I put this in. So this time, the same sequence, n is 2, so 3 times 2 is 6, minus 1 gives me 5. I'm then going to put n equals 3 in for the third number. 3 times 3 is 9, minus 1 equals 8. Then n equals 4. 3 times 4 is 12, minus 1 is 11. And finally, n equals 5. If I'm doing the first 5, 3 times 5 is 15. 15 minus 1 is 14. And I could keep going, but I don't need to keep going because the question will tell me how many terms you want to get. It's normally the first 5, or it might say, what is the 20th term? And that's great because all you need to do, if you want the 20th term, so the 20th term, you would just do 3 times 20, which is 60, minus 1, which is 59. So it's so quick to find the different terms, and we'll look at using this later on. But this is a formula. You use it in science, in business, in maths, in all sorts of things. This is a formula. These n's can mean something, so it's really important to get this formula. This is what you're often looking for. Okay? So, hopefully that makes sense. I want you now, I'm going to put some sequences on the board, and I want you to write down the first 5 terms for each of these sequences. Some people like to do it in a table like that or like that. It is up to you. So you could do it in a table like this. You can call this t if you want, but you don't need to. So 2 times 1 for this one is 3. So the first one will be 3. What am I talking about? 2 times 1 is certainly not 3. 2 times 1 is 2, plus 1 gives me 3. So the first one will be 3 in there. Okay, you could then do 2 times 2 plus 1. So 2 times 2 is 4, plus 1 is 5. See if you can work out the rest, see if you can do those questions there, work out the sequences. I don't mind how you set it out, I don't mind how you do it either. You might find some shortcuts. If you find some good shortcuts for doing this, brilliant. Okay, we'll talk about those later, but look for the shortcuts. Okay, let me know in the chat if you don't quite understand that. I know this is quite a difficult thing, especially if you have not done it before, but this is what sequences are all about, particularly moving towards GCSE. Okay, let's have a look.
I've not done that one.
This is the problem. This is the first time you've done something. You've not got about the first time, and you've had this crazy breakdown about it. And as well, what did I tell you from the beginning to use when we did it? Everyone, if you use the wood, it would be fine, wouldn't it? Okay, so the maths you forgot, you can do it again. Right, this time was good. Well, yeah, perfect.
What was that one for?
Oh, nothing, so yeah, I just got some parts, so you know that. So you just do points and so on. Yeah, good, perfect, fine. Good. Okay, so let's do that one. I'll check that before I take that, do the name of that, and then go out there and have a go through some of the we need to know, isn't it? We need to know, I thought that was good. Or if you just want to use that one, you can ignore those and keep it maths, and you just cut one out. That be better? Yeah? Okay. So just without this one. That's not bad, is it? So let's do one for each one. One go there for you. Okay, right, just so one more time, we'll go through this first one again. If you're okay with this, just go on. I'm going to go through the first one really nice and slowly for you. Once you get this, it's great. You can do it really, really quickly, but this is the most important part of the lesson, really. So the first one I'm going to go through now. So the sequence is 2n plus 1. I've got my table here. This is quite simple, just telling me what n is going to be. So n is going to be 1, 2, 3, 4, and 5. Okay, so the first thing I'm going to do is I'm going to take this sequence here and I'm going to replace it with 1. So I'm going to put n as 1. So the first one, n equals 1. Okay? So if n equals 1 in this sequence, I'm doing 2 times 1, which is 2. Then I'm going to plus 1 to it, and my answer is 3. That's the answer you want. 3 is the first number in this sequence. So you can just write it there, or if you're using a table, you can put it in there. Okay, it doesn't matter where you put it. The next one, I'm then going to do n equals 2, because that's my next number in the sequence. So if n equals 2, 2 times 2 is 4, plus 1 gives me 5. So 5 will be my next number in the sequence. You're then going to do n equals 3, because that's the next number, the third number in the sequence. So 2 times 3 is 6, plus 1 equals 7. Then we're going to do n equals 4. So 2 times 4 is 8, plus 1 equals 9. And finally, n equals 5. 2 times 5 is 10, plus 1 equals 11. So my sequence goes 3, 5, 7, 9, 11. As long as you've got all 5 of those numbers written down, it does not matter. Even if you've just gone straight to this, if you've just written down straight away, if you've written down 3, 5, 7, 9, 11, you just got the full marks of that question. Okay? Hopefully that makes sense now to some of you. I know this is tricky, but once you get to grips with it, it's so fast to do this. It really, really is. Be very careful. I'll put some really hard ones, those as hard as you would ever get on the foundation paper for GCSE. Some of those will be in the higher paper as well because they've got squares in them. Tracy Scullion as well seems to have spotted, or I'm not sure if that's your actual name, it's probably your mum's name, seems to have spotted a really nice pattern there, a shortcut saying you add 5 on for each one. Okay, nothing wrong with that. Someone else has spotted one as well. That's that person's name. Stevie Thomas has spotted a pattern as well and said you can easily repeat it, just be careful with that. Not going to be the case for absolutely all of those. If you still don't understand, please let me know. Okay, if you're on the second one, we're still struggling a bit, the second one, this means 5 times n plus 6. So whatever n is, you times it by 5 and then add 6 to it. So I want you to just pretend to start with that n is 1 and work out that, and that's your first number. So you're doing 5 times 1 plus 6, write down the answer. That is the first answer that goes in that box or just on your paper. So work that one out first, and then we'll get to the next bit. with you. Don't touch it yet. Which hand are you putting on first? The big hand or the little hand?
The big hand.
Right, well that's it. So that's brilliant. The big hand's right, but where should the quarter to 8's good actually, that's good. Okay, so this one here, look at this one there.
Yeah.
What's that one supposed to be? 25 past 8, yeah. If it's 25 past 8, where should the little hand be?
It should be there.
Yeah, it should be more, so that's why. Try and do the little hand first, but that's, so that.
It is confusing, isn't
yeah,
it?
if you do that, yeah it is. If you do the little hand first, it will help. So that one, 20 past 2, where should the little hand be?
There.
Yeah, okay, so just check your little hands on that one. Yeah, just check your little hands on, even that one, 9:30, where should the little hand be for 9:30?
There.
Yeah, so just check your little hand again. The big hands are brilliant, so you would get, some of those you get completely right, some of them with the little hand you get just a little bit wrong with that. That's really good there, Ron. Okay, just 30 seconds more. Okay, I'm just going to go through the second one again. So the second one, 5n plus 6. So when n is 1, I'm going to do 5 times 1 plus 6. When n is 2, I'm going to do 5 times 2 plus 6. When n is 3, I'm going to do 5 times 3 plus 6. When n equals 4, 5 times 4 plus 6. When n equals 5, 5 times 5 plus 6. So that's what you're actually doing. Write down that working out if you want to. So 5 times 1 is 5, plus 6 is 11, 5 times 2 is 10, plus 6 is 16, 5 times 3 is 15, plus 6.
Yeah.
Okay, you don't use a table for each one at all, you can just write them down. So 5n plus 6 were the answers for the first one there. Okay, I just want to look at question 6 as well, because this one is really easy to get wrong, and then I will put the answers on the board for you. So question 6, 6n, 6 minus 2n. Okay, 6 minus 2n. So when n is 1, okay, let's just look what we're doing here. We're doing 6 minus 2 times 1. Okay, 2 times 1 is 2. So this is 6 minus 2. 6 minus 2 equals 4. When n equals 2, we've got 6 minus 2 times 2. 2 times 2 is 4. So 6 minus 4 equals 2. When n equals 3, we've got 6 minus 2 times 3. which is 6 minus 6, which equals 0. When n equals 4, we've got 6 minus 2 times 4, which is 6 minus 8, which is negative 2. It's going down in 2s, and the next one has to be negative 4. So they get tricky with the minus signs in there. So your answer you should have had should be these sequences here. Remember with the last one we are squaring and then timesing by 2 and then adding n. Okay, if you have never done this before, alright, if you are getting the first 4 correct, that is absolutely brilliant. Okay, if you've never done this before, the first 4, if you've got those, fantastic. Okay, do not worry about the rest of them. We'll get more practice with this. You can practice on the exam questions I've got as well. So just, if you've got this first bit, brilliant. You may notice this is very similar to if you're drawing straight line graphs. If you've done that topic where you're drawing graphs, it is basically the same thing. Except we put an n in with graphs, it's always an x and there's a y at the beginning as well. Okay, so just check your answers. Okay, there. Well done, whoever that person is that's in year 6 and doing this, outstanding. Have you changed these there? The little hands, have you changed them?
Yeah, I used the hands.
Okay, yeah, that's good. Okay, that's better. Right, let's go draw those shapes now, okay? Oh, there's a superstar challenge as well. You get a certificate if you can do that.
I'm watching
I think you'll be easy.
No, I can't do it.
Okay, go to the kitchen and do your work. The kitchen there. Got the other shapes as well, haven't you? Go on. Okay, right, so, next bit. Kind of working backwards. So, finding the nth term can be extremely useful for solving problems involving sequences. So, sometimes you are given a sequence and you need to find your nth term. So, what is the question? If this was the answer, what was the question? Okay, if this is the answer, what was the question? Just before we do this, if we look back at these answers, okay, this is a 2n plus 1 sequence and it goes up in 2 each time. This is a 5n plus 6 sequence, it goes up in 5s each time. This is a 3n minus 2 sequence, it goes up in 3s each time. This is a minus 2n sequence, it goes down in 2s each time. So maybe that will give you a tip about how to answer that there. Okay, so what is the nth term of this sequence? If you can work it out, post it on the chat please. If you can work out what you think the formula is that generates this sequence. Absolutely brilliant. Some of the ages here managing this work is absolutely fantastic. Okay, this is really, really good problem solving. Well done, Finn. Loving that answer there. That was good to me. Okay, right, let's have a look at this. Some really good answers there. You're all thinking about the right thing. The first thing to spot is the gap. Okay, so it's going up in 3s. And I always do this in my sequences. I number them at the top. 1, 2, 3, 4, 5. Because that is the first term, the second term, the third term, the fourth term, the fifth term. Okay? And then you look at the gap. So this is going up, each time it's going up in threes. Now the mistake that a lot of people do is because they think it goes up in threes, they think this is going to have +3 on the end of it. But it's not. It's in the 3 times tables. The 3 times tables go up in threes. So this is to do with the 3 times tables, multiples of 3. So to check it's a multiple of 3, we are going to write down 3n. So it's definitely a 3n sequence. Okay? What we're doing here is so useful for maths and really tricky science experiments as well. You'll find a formula in the end by looking at your patterns. Okay, so 3n. We know it's to do with 3n. Now we need to kind of test it out. If I did 3 times 1, because that's what 3n means, 3 times 1 would only give me 3. If I did 2 times 3, 2 times 3 would give me 6. If I did 3 times 3, 3 times 3 would give me 9. So this isn't quite right. It's almost there, but it's not quite right. So I then look at this number here and think, well, I'm only getting 9 with 3n, so how can I get from 9 to 11? How can I get from 6 to 8? How can I get from 3 to 5? And you should see, you just need to add a little bit on. You just need to add on 2. So it's +2. So at GCSE, this would be a 2-mark question in your exam. Okay, a 2-mark question and a grade 4. So this is already at a GCSE pass grade. So this is really important to be able to do this if you want to get the grade, at least the grade that you want for all your jobs and everything moving forward. So 3n will get you 1 mark and then +2. So the first thing is make sure you put the gap in front of the n. And then you should be able to work out the other one. It really helps to number those up. There are a few other kind of shortcut ways to do it. I'm not going to show you the shortcut because I want you to, it's better to understand why this works for some of the really tough questions they come up with at GCSE. Okay, so can we have a look at some of these now? So all I want you to do for this is I want you to find the nth term for each of these sequences. The one in red is particularly difficult. It is a much more difficult sequence to handle. That's why I put it in red. So just keep your eye on that one. I'd be very impressed if anyone can manage that. So have a go at this. I want you to write down the nth term for each sequence just on your paper or whiteboards at home. There's no need to post this on the chat. Any problems, please let me know. Okay? All those people that got 3n + 2 there as well. Brilliant. Absolutely fantastic. Okay. What's wrong with it? Why are you saying negative? Okay, you're just brilliant.
I'm really worried about that spider.
Well, I'll catch it after this, okay? Right, that's brilliant there. Right, so now let's just try and do the
Shape thing.
shape ones with a nice ruler, okay? And I'll hunt down that spider and find it, okay? That's fantastic, that. Well done.
How should I do the shape one?
Yeah, do the shape one on the...
But how should I do it?
I just use a square grid, so why not move it out here from here? You've got 2 spaces, haven't you? You've only got 2 shapes to do. You've got shape to do there, shape to do there. Okay? Okay, when we're doing vertices, draw vertices with dots and join them up. So, I'll make it big. I'll fill out things. Big you make it easy. Okay, if anyone needs help with this bit, please let me know. Some of these vertices it like a regular number. Okay, so like there. Okay, so we've got 1, 2, 3, 4. So we can form a word for this direction. Okay. But that's in the same line, so that's going to be one straight line. So you change direction from there. 1, 2, 3, 4, 5, 6. Okay. Oh, we go there, and we go in like that. 1, 2, 3, 4, 5, 6. The third one is a takeaway, correct? Okay, so you don't always have to add something on at the end. You can take it away at the end as well to make it work. There's nothing wrong with doing that at all.
It's actually
That's good. Well, no, it shouldn't be decade. It should be 8 sides.
I counted them. I don't need to work just to check that. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Always use a rule, it will help. Then 5, then 7, then 9. What did we say that sequence had something to do with? We said something it had to do with. It wasn't just times, it was something else. See if you can remember what we said at the beginning, and that might help you get an incredibly difficult sequence at the end there. I'm just going to go through the first one in case you're just so you can check your answer if you're a bit stuck. So, the first one, the first thing we know is if it's going 8, 10, 12, 14, 16, we know it's going up in 2. So I'm just going to number it 1, 2, 3, 4, 5. I know it's going up in 2 each time. So I know straight away the formula starts with 2n. Because it's times in by 2. Okay? I then test it out. And this is my testing out bit. So, 2 times 1, if n is 1, if n is 1 there, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. So it doesn't quite match up with my sequence there. But I just look at this number and think, how do I get from 2 to 8? How do I get from 4 to 10? How do I get from 6 to 12? And you can see you need to plus 6 on each time. So my sequence, my nth term, is 2n plus 6. And that's how you find the nth term for that sequence there. Have a go at the next one. Third one's very similar. 5 and 6. They get pretty tricky there if you ask me. I think there's a really difficult ones, but the first 4 should be very similar to that one there. Okay, we're still not quite there with the optic now, are we? Well done, people that lasted out the last one. As I said, if you've never done this before as well, if you can do those first 4, that is unbelievable. Okay, we would normally, in a normal maths lesson, we'd do the whole lesson on the first bit we've done, and then we do the second part, the second lesson on this. Okay, so we're going quite fast, but it's a revision lesson for people that have already done this. But some of you are trying your best to just even handle this for the first time, which is incredible. Okay. Right, so I'm going to give you 30 seconds more, just try and finish the last one you're on. Again, well done if you've done that last one. That's a really tough sequence there. Well done people that get it now, if not the first time, fantastic. Yeah, number 5 is tough. I'll give you a clue with number 5. This one is going down in 2s. So number 5, it's not going to be 2n, it's going to be negative 2n. So number 5 will start with negative 2n for that one, minus 2n. So it's going to be minus 2n and then plus something, I imagine, or you could put it the other way around, but that's why that one's much more difficult. Yeah, good. Okay. Okay, brilliant. Okay, what?
Okay, so I've done my work. So what can I do?
You can watch some TV for a bit. I'm going to go in there, do you?
Have the iPad.
No, I'm using the iPad.
Or anything I can use.
You can do some Lego or something.
How long do you think you'll be?
Yeah. Do some more maths if you want. Okay, right, so I'm going to give you the answers for these. As so we've got 2n plus 6 for the first one, 3n plus 4, 4n minus 1, 7n minus 8. We've got negative 2n plus 9. So if you do negative 2 times 1, you get negative 2. You need to get from negative 2 to 7, you need to plus 9. Or you might put it that way round instead, it doesn't matter. Minus 4 and plus 8. And this one, remember we said if it's going up in 3, then 5, then 7, then 9. Okay, if it's going up in those bits, then it's going to be to do with n squared. So you would do for this one.
Daddy.
Yeah, sort yourself out, okay?
I'll just watch it here.
So we got drama because there's a spider in the other room, so I can't find it. So we've got drama with my 6-year-old. Right. Okay. So 1, 2, 3, 4, 5. So this sequence here was 2, 5, 10, 17, 26. So n squared. 1 times 1 will be 1. 2 times 2 will be 4. 3 times 3 will be 9. 4 squared will be 16. 5 squared will be 25. And you should spot, it's not quite there, is it? But we can add 1. So it's n squared plus 1. So I've put a really challenging one in there for the end. Okay? All right. Okay, we are going to now look at why this can be useful. Okay? So, the nth term is really useful. So, I want you to look at this question here. The first bit, nice and easy. They always put an easy one on first and then they put a difficult one on. And I'm going to give you a hint here. Using the nth term, finding the nth term can help you with this question. Okay? So try and answer that and see how you get on. Okay? The nth term will help you with part 2 massively. Okay, and then we just got one more question after this, and then we'll stop. We've got through a lot of work today. This is probably one of the hardest things we've done, so really good work.
I can do a wash cycle for you.
So, can anyone find the 100th term in this sequence? And if you did get this in an exam, if you find the nth term anyway, you always get a mark for it. You will always get a mark for that in any tough sequence question. If you find the nth term, the thing we've just done, then you will get yourself a mark, and then you can use it to help you get the 100th term. Okay, anyone managed to work out the 100th term? Okay, right, I'm going to show you how this works, and this will hopefully show you how why the nth term is important. So the 6th term, it's going up in 4, so the 6th term will be 29. So let's find the nth term first. So the nth term, it's going up in 4s, so we know it's going to be to do with 4n. 4 times 1 is 5, 4 times 2 is 8, 4 times 3 is 12, so each time, 4 times 1 is 4, sorry, so each time we need to add 5. So the nth term is 4n plus 5. Okay? If we've got our nth term, we can then say, well, to get to our 100th term, we can just put n equals 100 into it. So we do 4 times 100 plus 5 is going to give me 405. Now what you cannot do is you can't think, well, I know my 5th term is 25, so what I can do is I can do, to get to 100, I can do that times 20 and get 500. Okay, that's not going to work. You've got to use this method here. Okay, the slow way would be to just count on and on and on to go 25, 29, 33 and so on, but that takes ages. So use the nth term as well. Okay, but if you can, to be honest, if you've just started this lesson, if this is the first time you've done this, if you can understand the first bit we've done there on just expanding sequences, that is fantastic. Okay, you're starting to really understand what algebra can be used for in terms of sequences. So we're going to finish there. I put some exam questions up as well. So there's some exam questions. I'll attach them to the comments here as well when I stop recording. Okay, well done for keeping up this work. Okay, tough lesson today, and please stay safe, and I will see you, possibly some of you tomorrow for Friday's lesson. We're going to look at some Facebook puzzles, some problems, the kind of things that come up to do with bid maths. And then there'll be some more GCSE lessons next week. Okay, thank you very much for all your hard work, and I will see you soon. Goodbye. Brilliant people that got those ones right as well. Some fantastic work there. If you do